Alright, today we do not need our mole map because we're learning how to do the next part of the next branch of the mole map, okay? So the mole map is going to be used tomorrow, it's not today. Today we are dealing with molar mass. So in order to find molar mass, we need our periodic table because we're using the numbers again, just like we did back in chapter 6, okay? So to use the numbers, we're using the atomic mass numbers, which are the decimal numbers on the periodic table. So if you look on your periodic table, any box has the decimals. Those are what we're dealing with today, okay? The atomic mass can be expressed in grams per mole. So the mass of 1 mole of an element is known as its molar mass. So the blank that you need to fill in is atomic mass, okay? Which this stuff can be a little bit different depending on what periodic table you look at, because sometimes some periodic tables have different decimals on the masses. And so our calculations might be slightly different, but it's okay because you're still going to basically get the same answer, okay? So these are some examples of molar masses, and I just looked at the periodic table and wrote them down. You don't have to write all 4 down, just write 1 or 2. But carbon has 12.01. Hydrogen's 1.01, sulfur 32.06, and sodium 22.99. Notice how all of them have the gram/moles, G/mole. And that is the unit, so it's showing that you have 1.01 grams of hydrogen is equal to 1 mole of hydrogen, okay? Because mole is a unit that's unifying the whole periodic table. The decimals, if you look at your periodic table, might be different. On a lot of periodic tables, instead of, for hydrogen, it will say 1.008 instead of 1.01. So that's the difference. Our calculations will be slightly different, but that's okay. It's still basically the same number. Same with carbon. Some periodic tables say 12.01111 or 1115, 3 ones and a 5. It's basically the same number still. So it's just, you have a more accurate periodic table if you have those more decimal places, okay? So when we're solving, all we have to do is we have to have a chemical formula. And when you look at that chemical formula, you're going to then find those elements on the periodic table, use their atomic masses, and add them together to get the total molar mass. And then it's also tricky if you have, for carbon dioxide, you have CO2. If there's a subscript on that element, then you need to multiply by that element. And so even though we're using polyatomic ions to write formulas, every element in the compound needs its own number to add it, okay? So we have 2 examples to do, and then we're done. So for the first one, we want to find the molar mass of sodium chloride. So this is where we have to think back in chapter 9 and go through all those questions to write a chemical formula. So if you need to look at your formula writing flip chart, you are more than welcome to, okay? So we have to determine what type it is to know how to write it. So is it an acid? No, it doesn't say the word acid. Is it molecular with prefixes? No, so that means it has to be ionic. So that means we need charges. Does it have a polyatomic ion? No. Chloride, IDE, is from the periodic table. So we need charges from the periodic table. So what's the charge on a sodium? +1. And what's the charge on a chlorine? -1. So do those charges balance to 0? Yes. We always start easy with our first example, right? So our formula will be NaCl. Okay. So now to find the molar mass, we have to look up the numbers for each of these elements and add them together. So can somebody tell me what the atomic mass number for sodium is? 22.990? Okay. And then what's the number for chlorine? 35.453. Who is completely lost and doesn't know where those numbers came from? Okay. When you look at your periodic table, and the boxes on the periodic table, it's the decimal numbers. Okay. So now, to find our answer, we just have to add them together. So what are they added together? A number. Yeah, what number? 58.443. Somebody else get that too? Okay. Last but not least, we need to No, we're not rounding. Oh, I forgot to tell you guys, the biggest and bestest thing, you don't have to round to sig figs on these because we're never going to use molar masses for sig figs. I'm so sorry. That is the key factor that you had to know today is you don't round to sig figs on this number, and this is the only time you don't round to sig figs. I'm sorry. We have to label it. Yeah, that's what we have to do. So G/mol. In the years past, when I have students who just come up and copy the answer key, apparently my G's sometimes look like 9s, and so they'll add a 9 and then not put G/mol, so then they get it wrong. So don't copy the answer key, basically.
Well, now I just know that it's a G now.
But still don't copy the answer key. Alright, so that's what we do. Our next example, we have subscripts, so it shows us how to do that. Okay? Is it all good if I erase? Alright. Yes. Okay. Example 4. This time we're going to do it for aluminum nitrate. Is it an acid?
No.
Is it molecular with prefixes?
No.
It's ionic. Does it have a polyatomic ion?
Yeah.
Yes. What is nitrate? What's the charge? -1. So this is where if you don't know these, you're going to be finding the wrong molar mass if you have wrong subscripts. So you still need to know them. Alright, what's the charge on an aluminum? +3. So, how am I going to write this formula? Yes. We got to put the nitrate in parentheses, so we have the whole thing, NO3 inside, and then a 3 on the outside. Okay? So, yes. Yep. So I'm going to write this down just so you can see. You don't have to do this every time if you don't want to. But we're going to, before we look up the numbers on the periodic table, let's count so we know how many of each element we have. So Al doesn't have a subscript, so that's just 1. Okay? Then we have to distribute this 3 to both of them. So we're multiplying when we distribute. Okay? So how many N's do we have now? 3, because it's 1 and then times 3 is 3. So we have 3 nitrogens. And then how many O's do we have? 3 times 3 gives us 9. Okay? So then when we look up the numbers, we have to multiply according to these subscripts. Okay? So what's the number for aluminum? 26.981. Okay. And then there's nothing, we don't have to multiply by anything, so I'm just going to leave it as is. For nitrogen, I have to multiply by 3. So 3 times, what is the number? 14.007. If you want to be super cool like me, you could call that 14.007. Or you could be even cooler and not do that. And then for oxygens, we have to multiply it by 9. What's that? 15.999. I don't have a cool one, but somebody in third hour came up with, you could say 15.999 if you wanted to. Alright, so then now we multiply and add together to get our final answer. So take 9 times 15 and 3 times 14 and add them all up, and what do you get? $212.993.
That's fine.
So what?
That's what you get at the end.
That's what you get at the end. It is correct, so I know it's right. And then grams mole, G/moles. Okay, so that's it. But very important to know, okay? When you come up to check your answer key, you might have, so like I had 993. This morning in first hour, we used a different periodic table, so instead of 993, we had like 994. Well, that's okay. It's still the same number, just the decimal places are off a little bit. So when you're finding molar mass, use your periodic table, do it like you know how to do, and if you come up and you are off just by the decimal places, but the overall number is very similar to what I have, don't change it. It's still okay. All right? You don't have to fix that. It's going to be okay.